The linear inequalities or equations or restrictions on the variables of a linear programming problem are called the constraints. The common region determined by all the constraints, including the non-negative constraints x is greater than or equal to 0 and y is greater than or equal to 0 of a linear programming problem, is called as the feasible region. The maximum or minimum value of the objective function is called the optimal solution. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss regarding very important and the easiest chapter, that is linear programming. What is the weightage you are going to get? So for the point of examination, you will get one mark question. Usually it's a definition type problem and one 6 marks question. So solving a problem using graphical method. So these two questions you may expect, that is one mark question and one 6 marks question, totally the 7 marks. Very important. This is in part E. This is in part A and this is in part E. Compulsory question. Now let us know a few definitions regarding this. Now, what is the definition of a linear programming? So, linear programming is one that is concerned with finding the optimal value. So, a linear programming problem is one which is dealing with finding the optimal value. Optimal value is nothing but finding the maximum or minimum value of a function, finding the maximum minimum value of a linear function of several variables. The variables may be x and y or x1 and y1, x1, x2, y1, y2, like that. So, a linear programming problem is one that concerned with finding the optimal value. Optimal value is nothing but finding the maximum or minimum value of a given linear function of several variables is called a linear programming problem. Now, let us know regarding the next definition, linear objective function. Linear objective function means a function of the form z is equal to ax plus by, where a and b are constants which has to be maximized or minimized, is called a linear objective function. A function of the form z is equal to ax plus by, where a and b are constants. A and b are constant. This function z is equal to ax plus by, which is to be maximized or minimized, is called a linear objective function, where a and b are constant, whereas the variables x and y are called the decision variables. Here x and y are called the decision variables, whereas a and b are the constants. So, any function of the form z is equal to ax plus by, where a and b are constant, which has to be maximized or minimized, is called a linear objective function, where a and b are constants, whereas the variables x and y are called as the decision variables. This is very important definition for 1 mark. So, these are all 1 mark question. You will definitely get one mark question from this. So, usually a linear objective function. Define a linear objective function. Now, let us come to the next definition. Define a feasible region. What is a feasible region? Feasible region is nothing but the common region. The common region determined by all the constraints, including the non-negative constraints, that is x is greater than or equal to 0 and y is greater than or equal to 0 of a linear programming problem, is called as a feasible region. The common region. Feasible region is nothing but the common region. The common region determined by all the constraints. Here the constraints are nothing but x and y. So, the common region determined by all the constraints, including the non-negative constraints x is greater than or equal to 0 and y is greater than or equal to 0 of a linear programming problem, is called as the feasible region. Now, after knowing the feasible region, one should have to find the feasible solution. Now, what is the definition for a feasible solution? The points within and on the boundary of the feasible region. The points within and on the boundary of the feasible region represents the feasible solution of the constraints. Points within and on the boundary. The points within within and on the boundary of a feasible region. Suppose this is x-axis, y-axis, then these are the points. This cuts the x intersects at a comma 0 and y intersect at 0 comma b. The boundary between these two will give the feasible solution. This is the feasible region. This is a feasible region. The points A and B within the boundary of the feasible region will represent the feasible solution. So here we are going to get the feasible solution. Okay. Now that is the difference between feasible region and the feasible solution. One is the points. The feasible region is nothing but the common region determined by all the constraints, including the non-negative constraints of a linear programming problem, is called feasible region. Points, the points within and on the boundary, the points within and on the boundary of the feasible region represents the feasible solution of a given linear programming problem. These two definitions are very important for the point of examination. Now let us come to the next definition, optimal solution. Any point in the feasible region that gives the optimal value. Here, what is the optimal value? The maximum or minimum value of the objective function is called the optimal solution. The optimal solution is nothing but any point on the feasible region, any point on the feasible region that gives the optimal value. That means that gives a maximum or minimum value of the objective function is called the optimal solution. Now, next definition of constraint. What is the definition of a constraint here? The linear inequalities or equations or restrictions on the variables of a linear programming problem are called the constraints. The linear inequalities or equations or restrictions on the variables of a linear programming problem are called the constraints. Here the constraints we are usually using is x is greater than or equal to 0 and y is greater than or equal to 0, which are the non-negative constraints. Okay. These are few definitions. So you may expect one definition for the point of examination for 1 mark. Here you are going to study finding the solution, finding the maximum or minimum value of a given equation by graphical method, solving a linear programming problem using graphical method. Let me take few examples how to solve these problems, and I will take one more problem of formation of a linear programming and finding the solution. Let me discuss the solution first. Now let us come to the first problem. Solve the following linear programming problem graphically. Maximize z is equal to 4x plus y subjected to the constraints x plus y is less than or equal to 50, 3x plus y is less than or equal to 90, and the non-negative restrictions are x is greater than or equal to 0, y is greater than or equal to 0. So here the objective function is max z is equal to 4x plus 3y, and the constraints, the subjected to the constraints are x plus y is less than or equal to 50, 3x plus y is less than or equal to 90, and the non-negative restrictions are x is greater than or equal to 0 and y is greater than or equal to 0. Now, let us come to the first step. Now, let me come to the solution. Now, find out the corner points first. Now, this is the objective function. Objective function is max z is equal to 4x plus y subjected to the constraints. Linear inequalities can be converted into the equalities. This can be written as equation 1 can be written as x plus y is equal to 50, and another equation is 3x plus y is equal to 90. Now let us solve this equation. Now put, very simple, first put x is equal to 0, then y is equal to 50. Therefore the coordinates of a is equal to 0 comma 50. Now put y is equal to 0. Now put y is equal to 0. If you put y is equal to 0, then x plus 0 is equal to 50. Therefore x is equal to 50. The point B, the coordinates of B is equal to 50 comma 0. So these are the coordinates of A and B for the first line. Similarly, solve the second equation. As usual, put x is equal to 0. Then you will get y is equal to 90. Therefore the coordinates of C is equal to 0 comma 90. Put y is equal to 0 now. Put y is equal to 0. Then this 3x plus 0 is equal to 90. 3x is equal to 90, or x is equal to 90 by 3 is equal to 30. So therefore the coordinates of D is equal to 30 comma 0. Now the coordinates of A is equal to 0 comma 50, B is equal to 50 comma 0, and C is equal to 0 comma 50, and D is equal to 30 comma 0. Now let us represent this on a graph. Take x-axis and y-axis. Now this can be represented on a graph. Let us draw a graph like this. Now this is x-axis and y-axis, the origin. On x-axis and y-axis, let us choose a suitable scale. Let us take on x-axis and y-axis 1 unit. 1 unit is equal to 10. So if 1 unit is equal to 10, just go on writing. This is 10, 20, 30, 40, 10, 20, 30, 40, like this. Okay, the first point is A is equal to 0 comma 50 and B is equal to 50 comma 0. Now let me represent in a graph sheet. Now this is x-axis and y-axis. What is A? A is equal to A. The value of A is 0 comma 50. A is 0 comma 50. X is equal to 0. This is 0 and y is equal to 50. So this is A. A is equal to 0 comma 50. Next B. What is B? B is equal to 50 comma 0. X is equal to 10, 20, 30, 40, 50. This is B. B is 50 comma 0. This point is B. Right. Now draw a line which passes through these 2 points AB. Since what is our first equation? X plus y is less than or equal to 50. So x is less than or equal to 50. If you put this here the x value and the y value, x plus y, which is less than or equal to 50. That means the feasible region will goes towards the origin. This is towards the origin. Curve, for the second curve, what are the points? A, what is C? C here 0 comma 90. C is 0 comma 90. X is 0. Y is equal to 90. So this is 0 comma 90. And D 30 comma 0. 30, this is 30 comma 0. D 30 comma 0. Since what is the condition here? The second equation is also 3x plus y is less than or equal to 90. 90 means which is less than or equal to means usually it will move towards the origin. So here this is the straight line. Just draw a straight line which passes to the point C and D. Since 3x plus y is less than or equal to 90, the feasible region is towards the origin. Now the corner points, let us identify the corner points. What are the corner points? So this is one corner point, and this is another corner point, and this is the another corner point. So therefore the corner points are 0 comma 0, A 0 comma 50, and E 20 comma 30, and B is equal to, what is D? D is equal to, that is 30 comma 0. See, if you draw a graph on a graph sheet, x-axis at 20 and y-axis at 30, therefore these are the corner points. So the intersecting point is 20 comma 30. So see here, x-axis it will intersect at this point, y-axis at this point. So therefore x is equal to 20 and y is equal to 30. This is the point of intersection. This is the point. Right. Now write down the corner points. Therefore the corner points, the corner points are O 0 comma 0. Again A is 0 comma 50, and then E, what is E? 20 comma 30, and then the value of D is equal to 30 comma 0. So these are the corner points O, A, E and D. So find out this is the feasible region and find out the feasible solution. Now let us simplify this. Now what are the corner points? Corner points, max, what is given? Z, objective function. Objective function is Z is equal to 4x plus y. Now write on this. At O comma O 0 comma 0, Z is equal to 0. Next at A, what is A? 0 comma 50. Z is equal to 0 plus 50. This is equal to 50. This is 50. At Next, what is the point we have? D, at D, 30 comma 0. What we will have? Z is equal to 4 into 30 plus 0, this is equal to 120. Again at E, what is E? E is 20 comma 30. 20 comma 30. Z is equal to 4 into 20 plus 30. 4 to the 80 plus 30 is equal to 110. This is 110. Okay. Now, what is required to find is the maximum value. What is the maximum value from the table? The maximum value is 120. This is maximum. So, therefore, the maximum is 120. So, the function therefore, Z maximum is equal to 120 at what are the point? At D, 30 comma 0. That's it. This is how you are going to solve a problem using graphical method. That's it. Hope you followed. Very simple and very, very important. So, if you solve this much, you will get 6 marks. Very simple. That's it. Find out the corner points and substitute. You will get the answer. That's it. Okay. Now, let us come to a similar problem. Let me take one more problem. Solve the following linear programming problem graphically. Maximum of Z is equal to 200x plus 500y subject to the constraints x plus 2y is greater than or equal to 10, 3x plus 4y is less than or equal to 24 and x is greater than or equal to 0 and y is greater than or equal to 0. Now, let us come to the solution. What is the objective function? Objective function is max Z is equal to 200x plus 500y. What are the constraints? The constraints subjected to the constraints, subjected to the constraints. Now, let us convert these inequalities into equalities. So, x plus 2y is equal to 10 and 3x plus 4y is equal to 24. Now, as usual, put x is equal to 0. You will get 2y is equal to 10, y is equal to 10 by 2 is 5. So, therefore, the first point A is equal to 0 comma 5. Similarly, put y is equal to 0. If you put y is equal to 0, then this becomes x plus 0 is equal to 10, x is equal to then, therefore, the value of b is equal to x comma y 0, 10 comma 0. Okay. Now, find out for the second equation. For the second equation, put x is equal to 0, then 4y is equal to 24, y is equal to 24 by 4. So, this is equal to 6. 6 4s are 24. So, therefore, the point C is equal to 0 comma 6. Now, you similarly put y is equal to 0. If you put y is equal to 0, this is 3x plus 0 is equal to 24. 3x is equal to 24. X is equal to 24 by 3. So, if you divide 24 by 3, 8 3s are. So, y is equal to, x is equal to 8. So, therefore, the point D, what is D? D is equal to 8 comma 0. So, these are the points. So, now, therefore, the points, what are the points? A is equal to 0 comma 5, B is equal to 10 comma 0 and C is equal to 0 comma 10 and D is equal to 8 comma 10. So, these are the corner points. Now, let us represent these points on a graph. So, take 1 unit. Let us take since the maximum value is 1 unit is equal to 1 centimeter. 1 unit is equal to 1 centimeter, represent it on a graph sheet. So, now let us write on first value A is equal to 0 comma 5. The graph is like this. Now, let us take scale 1 centimeter is equal to 1 unit. Now, here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the x-axis. Again 1, 2, 3, 4, 5, 6, 7, 8, 9, 4. This is 5, 6, 7 on the y-axis. Now, let us find out the first point. What is the first point? A 0 comma 5, x is 0, y is equal to 5. 1, 2, 3, 4, 5. This is A, 0 comma 5. Now, B, let us come to B. What is B? 10 comma 0. X is equal to 10, y is equal to 0. X is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This is the point. So, this is B. B, 10 comma 0. What is the curve? So, the equation is, what is the first equation we have? X plus 2y is greater than or equal to 10. x plus 2y. See here the equation is, this is the equation, x plus 2y is greater than or equal to 10. Greater than or equal to 10. So, greater than or equal to 10. This means the feasible region is away from the origin. This will goes in the upward direction. So, x plus 2y is greater than or equal to 0. This is maximum is here it is 10, and greater than or equal to 10 here is it will goes away from the origin. So, the feasible region is in the upward direction for this equation. So, the upward direction, we are going to write the feasible region, the upward direction, right. Now, come to the second curve. What is the second curve? We have C, point C is equal to 0, 6. C is equal to 0, 6 and D is equal to 8, 0. C 0, 6, X is 0 and Y is equal to 6. So, this is C, 0, 6. And the last point D is equal to 8, 0. X is 8 and 8, 0. This is 8, 0. Draw the graph. So, if you draw a straight line passing through the point C and D. Now, what is the condition? What is the curve we have? The second curve is 3x plus 4y is less than or equal to 24. 3x plus 4y which is less than or equal to 24. So, 3x plus 4y is less than or equal to 24. So, again this is less than or equal to. This line less than or equal to means again this will goes in the downwards direction. The feasible region is towards the downwards region. So, therefore, here A, C, B is the feasible region. This is the feasible region. The shaded region will indicate the feasible region for the given problem. So, the corner points are A, B and C. Therefore, A is equal to 0, 5 and B. What is B? 4, 3 and what is C? C is equal to 0, 6 are the corner points. These are the corner points. Okay. See here, one curve x plus 2y is greater than or equal to 10 means it will move away from the origin. The feasible region is above the origin. So, in this direction. And another one is x plus 3x plus 4y is in the downwards direction, less than or equal to means downwards. Just keep it in mind. Greater than or equal to away from the origin, less than or equal to that is towards the origin. So, this is the feasible region. A, B and C is the feasible region. So, which will satisfy the condition 3x plus 4y is less than or equal to 24 and x plus 2y is greater than or equal to 10. Now, the corner points are 0, 5, 4, 3 and 0, 6. Now, find out the maximum and minimum value for this function. Now, let us go to this. Therefore, the points, the corner points and the objective function is what is given? Z is equal to what is Z? 200x plus 500y. 200x plus 500y. Now, at what are the corner point? At 0, 5, at A 0, 5, at B, what is B? 4, 3 and at C, what is C? 0, 6. So, these are the corner points. So, at B and at C. At B, Z is equal to, so this Z is equal to 200 into x is 0 plus 500 into 5. 5 5s are 25, 2500 it is. Now, at this Z is equal to, what is this? 200 into 4 plus 500 into 3. What is this equal to? 800 plus 5 3 is 15, 1500. 800 plus 1500 is 2300. 2300 it is. Now, at C 0, 6, Z is equal to 0 plus 500 into 6, 30. This is 3000. 3000. Now, what is required to find? Just see the objective function. Maximum Z, max Z is equal to So the maximum value is 3000. This is the maximum value. Maximum. So therefore, the maximum value is this. Therefore, Z maximum is equal to 3000 at what are the corner points? 0, 6. That's it. At 0, 6, the maximum value is 3000 rupees. This is 3000. 3000 is the maximum at 0, 6. Hope you followed. Suppose if you want to find the minimum value is, this is the minimum value. Note, if it is required to find the minimum value, Z minimum is equal to 2300. 2300 at what are the points? B, 4, 3. Suppose if it is required to find, if you want to find the minimum value is 2300 at 4, 3. Sometimes they may ask find the maximum and the minimum. Maximum is 3000 at 0, 6. Minimum is 2300 at 4, 3. That's it. Okay. Hope you followed. Now let us come to the next problem. Solve the following linear programming problem graphically. Minimize and maximize. So here minimum value as well as the maximum value is to be determined. What is the objective function? Z is equal to 3x plus y. Subjected to the constraints STC. The constraints are x plus 3y is less than or equal to 60. X plus y is greater than or equal to 10. And x is less than or equal to y. And x is greater than or equal to 0. Y is greater than or equal to 0. So here there are three equations. First equation, x plus 3y less than or equal to 60. Second, x plus y greater than or equal to 10. And the third equation is x is less than or equal to y. So this is also an equation. So usually the students will get confused. So here there are three equations. This is very, very important problem for 2022 examination. I may expect this type of problem for 6 marks. Now let us come to the solution. Now first, let us write down the first, convert the inequalities into equalities, that is x plus 3y is equal to 60. Then second equation, x plus y is equal to 10, and the third equation, x is equal to y. Right. Now put x is equal to 0. If you put x is equal to 0, 3y is equal to 60, y is equal to 60 by 3 means 20. Therefore, the first point a is equal to 0, 20. Similarly, put y is equal to 0, then x is equal to 60. The point B is equal to 60, 0. First point. Second point for the first curve. Similarly, put x is equal to 0. You will get y is equal to 10. Therefore, C is equal to 0, 10. Similarly, put y is equal to 0. You will get x is equal to 10. Therefore, the coordinates of D is equal to 10, 0. 10, 0. Now let us come to the next curve. So here what is given? X is equal to y, that is y is equal to x is a straight line which passes through the origin. So y is equal to x coordinate and y coordinate are same. You can choose any value. You can start with 5. When x is equal to 5, y is also equal to 5. When x is equal to 10, y is also equal to 10. When x is equal to 15, y is also 15. When x is equal to 20, y is also equal to 20. So you can choose any points, 5, 5, 10, 10, 15, 15 and 20, 20. Now these are the points. Now let us consider this D and E. Okay. Now let us represent this on a graph sheet. Now here, what is the graph we are going to get? This is x-axis, y-axis and the origin. Now take each unit is equal to 10, 10. So this is or 5, 5, 5, 10, 15, 20, 25 like this, 5, 10, 15, 20, 25, 30 like this. Now let us represent the first curve. First A 0, 20. So x is equal to 0, y is equal to 20. Somewhere you will get 0, 20 and B 60, 0. 60, 0. Let us assume this is 60, 0. A straight line. We are going to draw a straight line. Okay, this is nothing but x plus 3y is less than or equal to 60 means the visible region is towards the origin. Now, second C 0, 10. X is 0, y is 10. x is equal to 10, y is equal to 0. So this is another. So A, B, C, D, a straight line. So this is nothing but, for the second equation, x plus y is greater than or equal to 10 means the feasible region is away from the origin, that is to away from the origin. Now the next equation is y is equal to x. You know, y is equal to x is nothing but a straight line which passes through the origins here. When x is equal to 5, y is equal to 5, and x is equal to 10, y is 10. When x is equal to 15, y is also 15. When x is equal to 20, y is also equal to 20. That means a straight line which passes through this. Now here this is nothing but x is less than or equal to y. X is less than or equal to y. So therefore this is the feasible region. So the graph will be like this. So 0, 0 for the first curve. For the first curve, what are the answer? What is A? A is equal to 0, 10. This is A. And B. B is equal to, this is B. 10, 10, 0. The first point is, this is actually A. 0, 20. X is equal to 0. X is equal to 0. Y is equal to 25, 10, 15, 20. 0, 20. And B, what is B? B is nothing but 60, 0. This is B. 60, 0. This is B. Now draw a line. This is the line. So since, what is the condition here given? X plus 3y, see here, x plus 3y is less than or equal to 60. X plus 3y is less than or equal to 60. Less than or equal to 60 means this is nothing but the feasible region is towards the origin. Now the second equation. What is the second equation? For C and D we have, so here 0, 10 and 10, 0. 0, 10, x is 0, y is equal to 10. This is one point. And D, 10, 0. This is another point. So a straight line like this. So here the points are C and D. This is C and D. A, B, C, D, straight line. Okay, since what is the condition given here? X plus y is greater than or equal to 10. So x plus y is greater than or equal to 10. So that means this is moving away from the origin. So one is towards the downwards direction, another one is away from the origin, upward direction. Now what are the 4 points? That is D 5, 5 and E 15, 15. So x is equal to this B 5, 5 and 15, 15. You can consider this as a E, A, B, C, D, E and F. Let us represent this as E and F. So these are the corner points. So what are the corner points? This is the feasible region. The corner points are A, B, D and C. These are the corner points. So this is very important concept. Here the corner points are this word, that is towards the y-axis. That is A, B, C and D. Therefore the corner points are A 0, 20. Then let us write down this point A. C. C is, what is C? 0, 10 and then we have B. B is equal to 5, 5 and E 15, 15. So these are the corner points. Okay. Now find out the maximum and minimum value. Now here at, what are the points? At A, B, C and A, B, C and E. Right. What is given? Objective function Z is equal to 3x plus 9y. So these are the corner points. Now C and E. At A, what is A? A is 0, 20. B 5, 5. C, what is C? 0, 10 and E 15, 15. Z is equal to 3 into 0 plus 9 into 20. This is 180. And this is 3 into 5 plus 9 into 5. This is equal to 15 plus 45. This is 60. Now at C, 0 plus 9 into 10, that is 90. Then at E, this is 3 into 15 plus 9 into 15. So 15 into 3 is 45 plus 15 into 9 is 135. So this is again equal to 180. Now these are the values of Z. So the corresponding values of Z are 180, 60, 90 and 180. Now what is required to find is the minimum and maximum. What is the minimum? This is the minimum value. Minimum. This is minimum. What is the maximum? This is the maximum. So there are two maximum values. So these are the maximum values. So this is maximum and this is also maximum. That means therefore Z minimum, the minimum value is 60 at what are the points? 5, 5. And Z maximum, Z is maximum, the maximum value is 180 at, there are 2 points. What are the points? One is 0, 20. Another point is 15, 15. So these are the values. So this is how we are going to solve. Anyway, this is very, very important problem. That's it. Okay. So writing the feasible region is very important. So since there are two curves, x is here. What is given? X is less than or equal to y. So x is less than or equal to y. X is less than or equal to y means x is equal to y or y is equal to x, a straight line which passes through the x is less than or equal to y. So here this is the shaded region, this is the feasible region. That's it. Now that's regarding this problem. Okay, hope you followed. Now let us come to the next problem. Let me take one more problem. Now write on this problem. See here what is given? Solve the following linear programming problem graphically. Minimize and maximize. Here also it is minimization as well as the maximization. Z is equal to x plus 2y subjected to the constraints x plus 2y is greater than or equal to 0, 2x minus y is less than or equal to 0 and 2x plus y is less than or equal to 200 and non-negative restrictions are x comma y greater than or equal to 0. Now let us find out the corner points. Now for this, now convert these inequalities into equalities. This can be done as x plus y is equal to 100. Another equation 2x minus y is equal to 0 and 2x plus y is equal to 200. Now put x is equal to 0. If you put x is equal to 0, then this becomes 2y is equal to 100, y is equal to 50. Therefore the first point A is equal to 0, 50. Similarly, put y is equal to 0. If you put y is equal to 0, then x is equal to 100. So therefore the point B is equal to 100, 0. 100, 0. These are the first points. Okay. Y is equal to 2x. Now since y is equal to 2x is again a straight line passing through the origin, now you can take any values, equal values. Suppose if I take x is equal to, put x is equal to 20, y is equal to 2 into 20, that's equal to 40. Therefore C is equal to 20, 40. Now let us take one more value. Suppose if x is equal to 50, then what is y? Y is equal to 2 into 50, that's equal to 100. So therefore the point D is equal to 50, 100. Okay. Now let us come to the third equation. Here also 2x plus y is equal to 200, put x is equal to 0, y is equal to 200, therefore DE, the point E is equal to 0 comma 200. Now put y is equal to 0, you will get 2x is equal to 200, x is equal to 100, F is equal to 100 comma 0. So these are the points. A 0 comma 50, B 10 comma 0, C 20 comma 40, D 50 comma 100, E 0 comma 100 and 0 comma 200, and F is equal to 100 comma 0. Let us represent this on a graph. Now take a suitable scale, that's it. Now I will draw the graph. X axis and y axis, the origin. Okay. On x axis and y axis, on x axis and y axis, the scale, suitable scale will be 1 unit is equal to 10. Let us consider each unit is equal to 10. So that is, this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Again this is 10, 20, 30, 40, 50, 60, 70. Okay. On the y-axis we have 200 maximum value. Let us take on the x-axis. This is 1 unit is equal to 10 on x-axis, and on y-axis 1 unit is equal to 20. So then this becomes 20, 40, 60. This is 10, 20, 30. Okay. Now draw the graph. What is the first point we have? A 0 comma 50. X is 0, y is 50. So here it is A 0 comma 50. Next B. What is B? 100 comma 0. 30, 40, 50, 60, 70, 80, 90, 100. This is 100 comma 0. Now draw a line. This is the line. That's it. So what is the equation here? X plus 2y is greater than or equal to 100. So x plus 2y is greater than or equal to 100. That means the feasible region is away from the origin. It is going upward direction. Let us come to the next second. What is C? 20 comma 40. X is 20. X is 20. Y is equal to 40. So you are going to get a point here. See, this is C. 20 comma 40. Next, then 50 comma 100. X is 50, 30, 40, 50 comma 100. So here it is 80 and 100. 10, 20, 30, 40 and 50. So 50 and 100. Here is the point. This is the point, that is D. 50 comma 100. Now that's nothing but a straight line. This is the straight line. Okay. What is the condition? X minus 2x minus y is less than or equal to 0. Now the third equation. For the third equation we have E 0 comma 200 and 100 comma 0. 0 comma 200. 0 comma 200. X is 0. Y is 200. So 20, 40, 60, 80. Yes. 20, 40, 60, 80, like this. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 200. What is that point? 0 comma E. 0 comma 200. And the next point is 100 comma 0. This 60, 70, 80, 90, 100. 100 comma 0. E, F. F, this is F. There are 200 commas. Now write down the curve. This is the line. What is this equation? So the curve is 2x plus y. This is 2x plus y is less than or equal to 200, this side. So this is the feasible region. So for the third curve, 2x minus y is equal to 2x. This is y is equal to 2x. So therefore this is the feasible region. So this is a feasible region. Now what are the corner points? These are the corner points. Okay. Therefore the corner points are A, E, D and C. These are the corner points. Now write down the solution for this. Now at value of z, z is equal to x plus 2y. At what are the points, corner points? A, E, D and C. What is A? We have A 0, 50, A. Then E 0, 200. Then D 50, 100. And C. What is C? C is equal to 20, 40. Now find out the values. That's it. Z is equal to 0 plus 2 into 50 is 100. This is equal to 100. Z is equal to 0 plus 2 into 100. 2 into 200 is 400. Next, Z is equal to 50 plus 2 into 100, 200. That's equal to 250. And at C, Z is equal to 20 plus 40 into 2, 80. This is equal to 100. Okay, these are the values of Z. Now, what is required to find? What is the objective function? Minimize and maximize. So, the minimum value, there are two minimum values. These are the minimum values. Minimum values are 100. So, there are two minimum values. This is one minimum value. This is another minimum. So, Z minimum is equal to 100 at, what are the points? At A 0, 50 and C 20, 40. Okay. What is the maximum value? 400. This is the maximum value. So, maximum, Z maximum is equal to 400 at, what are the point? At E. What is E? 0, 200. Maximum at E. E is 0, 200. This is how we are going to solve. That's it. Okay. Let us meet with a different concept in the next class. Thank you. Thank you very much.